In this video, I'm going to be talking about some more ways to solve quadratic equations, so let's get started. So we're going to start by completing the square, which is a method used by many people, and it's probably one of the most effective ways to solve quadratics because you can use it to solve any quadratic without having to remember some formula. So when we complete the square, it's pretty simple. We're using some manipulations and some factorizations. So when we use useful factorization, we can use the squares of binomials factorization. So if you don't remember, that's a plus b squared. And when we square binomials, we square the first term. The middle term is a product of the terms inside multiplied by 2. And then we square the last term. That's the squares of binomials factorization. So we're going to use the same thing to solve a quadratic here. Let's say we have x squared plus 4x equals 14. So over here we can't fact. We could see if we can factor this. I don't think it's useful here. So we can use squares of binomials to complete the square. And when we complete the square, we use our squares of binomials factorization as implied. So over here we want to convert x squared. Then we want to convert the quadratic term and the linear term, and you want to make these squares a product of binomials. So, and we want to square the binomials. So in the first term, I'm going to have an x, and we're going to square the x off. And in order to get this linear term of 4x, I'm going to have a 2 over here. So 2x, we multiply the terms inside, we multiply that by 2. That's how we get the middle term over here. So we're going to have a 2 over here, and we're going to square that off. So we're going to have x squared plus a 4x, which is all listed. But we're also going to have an extra term of 4, since 2 squared is 4. And since we added 4 to this side, we have to add 4 to the other side. So 14 plus 4 is 18. And we've successfully done that. Now, since we've added it to that side, we don't really need to worry about it anymore. So we can just forget about the 4 over here. We have x. So right now we have x plus 2 squared. We'll write this as a square of binomials equals 18. So we already have the plus 4 here, so we don't need to worry about it here. So that's why we removed the 4. So technically we still have the 4 term, but it's in the product of binomials form. So obviously now what we want to do is x plus 2 squared can be written as, so this can just be written as the square root of 18 squared. And squaring a square root gets rid of the radical, so we're just going to have 18. So this is essentially the same thing. Now, if we want to solve this, we just get rid of the squares. And then we have x plus 2 equals root 18. And to solve this, well, we have x is equal to, we bring the 2 over the other side, we have a negative 2, and then we're going to have a root 18. And since this is a quadratic equation, we're going to have a plus minus as we saw in our other units. So really our two solutions are negative 2 plus root 18 and negative 2 minus root 18 can be written like this. So that's our answer. That's how we complete the square to solve quadratic equations. Now, let's change the quadratic a little bit. And let's say we have something like, let's say we have something a little more complicated, right? So let's say we have an equation like 3x squared plus 12x plus 1 equals 0. And here we know how to solve quadratics by completing the square when the coefficient of the quadratic term is 1. So over here, since it's an equation, we can just divide every single term some way, and we can manipulate the equation. Here's where the special manipulations comes in. we can manipulate this equation to get rid of 3. And the way we're going to do that is divide every single term here by the coefficient of the quadratic term, which is 3. So if I divide this by 3, the 3's cancel. I'm going to have an x squared term. If 12x divided by 3 is going to give me a 4x. And 1 divided by 3 is obviously 1/3. And 0 divided by 3 is just 0. So now we have a quadratic that we know how to deal with. So x squared plus 4x can be written as a product of binomials, or square of binomials. So x plus 2 squared. And then over here we're going to have x squared plus 4x plus 4, which is an extra 4. We also need to bring the 1/3 to the other side, so we're obviously just going to have that. But since we also have a 4 over here, we're going to need a 4 over there as well. So since we have a 4 over on that side, we're going to have a -3 plus 4 over here. So that's how we're going to deal with that. So if we have -1/3 plus 4, well, if we just find common denominator, we're going to have 11/3. So x plus 2 squared is going to be 11/3. Now we need to convert this into the square root of 11/3. Now, obviously, this can be also just be written as we can write this as root 11 divided by root 3 squared, which will obviously get rid of the square roots, or we can square each term top and bottom. But as we saw in the previous video, we like to rationalize our denominator. So when we rationalize the denominator, we can just remove the squares. Alright, and now we can rationalize the denominator. Root 3 squared is 3, and that's just root 33. And now we really see that x plus 2 is equal to root 33/3. That's our real thing. And if we manipulate this equation, we're going to have a -2 plus minus root 33/3 as our answer. So that's how you solve quadratic equations by completing the square. Hopefully this video helped, and that is how to solve quadratic equations by completing the square.